Okay, we were just talking about air molecules. So every time one of those air molecules bounces into the side of the container, it creates a little bit of pressure. It doesn't create much pressure, but if you had 1 trillion of them, and you had trillions of impacts happening every second, that could actually create a decent amount of pressure. And that's what happens with the air. And that's why we can feel it on the insides of our cheeks. Okay, there's one more thing about how air pressure works that we want to cover before we move on. This is a diagram. So there's 3 cubes now, all these little blue things, those are air molecules. So again, imagine we're zooming in over a billion times. And the thing about air pressure is, and this makes sense, is if you put more air into a space, a fixed space, you create more pressure. So you got more air molecules, there are more impacts on the sides of the container, you get more pressure. And then A, you pull air out of the container, you get less pressure. And you can feel that with your cheeks. Close your lips. Pull in a little bit of air, not much pressure. Push in more air, a little bit more pressure here would be, and push in a bunch of air, and you got lots of pressure with C. Okay, that brings us to the next question. Very astute question. Is air pressure strong enough to crush things like this big metal tanker that you tell me is stronger even than an Indian water tanker? Well, I will tell you, and you can probably guess this already, that the answer to that question is definitely yes. And that video we saw a little bit of at the beginning of the class is going to help us out with that. Check this out. This is another example of air pressure, just like our tanker.
You know, you look at the surface area of this thing, it's probably something like 20 square feet. So we're talking about 40,000 pounds of force on this thing. That's like one of those 40-foot school buses full of kids. You lay one of those on this, you're going to crush the 55-gallon drum.
We'll accelerate the process by pouring ice water over the drum.
Watch out, guys. This might be...
Soda can. The cold water turns the steam inside into liquid and creates a vacuum in seconds.
Cartoons, you know, when they go over the cliff, the water doesn't know where to go. It's like, what happened?
Alright, don't worry about all that technical talk they were talking about. The point is that the air pressure around that drum is what crushed it. And you know that it had to be there already because it crushed it so fast. It wasn't like something that they were increasing or decreasing or anything. No. It had to be there at a constant amount of force at all times. And you saw how quickly it crushed that 55-gallon drum, which is about 215 liters, I don't know. Okay. Now, in order to understand how this works, or how it's possible that air could create that much pressure, I want you to compare it to water. So if you think about a small drop of water here, a little drop of water in your hand, that wouldn't create too much pressure, but it would create pressure because you would feel it on your hand, right? And we know that to feel things is because of pressure, because they're pushing back on us. That's how we feel them. So we know this little drop of water has a little bit of pressure. So what if you had millions and millions of liters of water? You had millions and millions of liters, which would be billions and billions of drops. Well, that's how much water is behind a typical dam. You see this concrete dam here is holding that river water back. So you can imagine that there's tremendous amounts of pressure pushing on this dam. And now, even though you normally can't see it because the dam is nice and strong and it holds the water back, I want to give you an example of how strong that pressure actually is. This is what happens when they open. There's usually gates on the dam, and this is what happens when they open those gates. You can see it and you can hear it. Here's the water behind the dam. Tremendous force that water is pushing out. Look at how calm it looks back here. Looks like it's not doing anything. dam looks fine, but listen to that force that it flows through that dam. Okay. I will tell you that the air in our atmosphere can be compared to the water behind that dam. Just like a little drop of water creates a little bit of pressure, but you've got billions and billions of drops of water that creates lots of pressure, it's the same with air. You can imagine if you had just a little bit of air, it wouldn't create that much pressure. But what if you had something like a whole lakh square meters of air? That would be tons of air. That's about how much air is in this football stadium right now. That could create a decent amount of pressure. Well, that's how much air is over us at all times. Actually, that's how much air is over just one of us. Just one person has a whole lakh square meters of air on top of them at all times. And that's because our atmosphere is so high. Our visible atmosphere is over 90 kilometers high. And it's so high, and there's so much air in the atmosphere, that there's actually a whole kilogram of pressure pushing on every square centimeter. Okay, that was a whole lot of metrics. A square centimeter is about the size of a rupee, right? There is a whole kilogram of pressure pressing on that rupee at all times. And that would mean there'd be about 70 kilograms of pressure pushing down on just your head. That would be like me standing on top of your head. Okay, let's check out one more example of air pressure, just in case you still don't believe me. And this is a really interesting one. It's going to show us a little bit more about how the strength of air pressure works. Okay, well, this woman has a ruler at the end of the table, no any wooden ruler, and you see what happens when she hits it. Now, she's going to put the same ruler on the table, cover it with a sheet of newspaper,
and hit it in a similar fashion.
and she's going to hit it again. The only difference is that the newspaper is sitting over the ruler. So before we perform this experiment, I have a question. When she hits the end of the ruler, what will happen? A, the ruler will fall off the table, that's what happened before. B, the newspaper will rip, and that seems pretty reasonable. C, the newspaper will get flung through the air, also pretty reasonable. Oops. Or D, the ruler will break. Okay, let's finish up that poll. I'll give you 30 seconds. Okay, now that we got the results of the poll,